Hi guys, well as you can see my batteries are no longer in the back of my car. I have them up in my office, and the reason for that is I plan to first of all get these two modules down to the same voltage as the rest. And what I mean by that is all of these other modules came out of a single battery pack. These two came out of a different battery pack and were sitting at a slightly higher voltage. So the plan is to get these two modules down to the same voltage as these ones. And to do that, I'm using this, which is battery tester stroke discharger type thing. You can buy these quite cheaply off eBay or Amazon or AliExpress. I'll put a link in the description down below to where you can get one of these. But this one is a 185 watt discharge unit, and the reason I know is that it's not because I remember buying it, it's because every time I turn this up, when it goes above 185 watts, it just turns off. Anyway, plan is to get these modules down to the same voltage as these modules. So I'm using this, and once I've got that done, the plan then is to try and hook up all of these battery modules to this BMS, which came out of the Nissan Leaf. I know it's not the right BMS for these modules, but batteries is batteries, BMSs is BMSs, give or take. It should hopefully work. We'll give it a try and see. But it does mean a lot of wiring will have to be done. I'll have to hook the whole pack up in a single loop to make up the full 400 odd volts or 300 odd volts, and then connect all the BMS wires to all of these. As you can see, if you look in there, there's a lot of connections to make. Okay guys, what I'm going to do now is to take you through what I'm doing to the battery modules to try and get the Nissan Leaf BMS connections connected to it or attached to it. First thing, this is one of the master modules. The eGolf has two types of modules this size. One type is the master, which holds the BMS on it, and the other one is the slave. They both look identical from the outside. The main difference is, hopefully you can see that, is this one has a black connection at this end, and at the other end it has an orange and a black. Now the black connection is for the CAN bus connection to the other modules, and I guess the master connection back into the car. And the orange sockets are for the BMS connectors going out to other modules. So basically this module has a BMS for, I'm not sure how many, I should know how many cells, it's maybe 16 cells, something like that. I'm not sure exactly, we need to check that up, but basically this module has the capability to balance 6 or 7 other modules, depending on whether they're double or single, or double or quad modules. This is a quad module, the smaller ones are doubles. I'll take the lid off and you'll see what I'm talking about. So, take the screw out, and we'll pop off the lid. Screw it over either side, and it just comes off like that. So this is the BMS module I'm talking about, and as you can see, these are the resistors for the BMS. I'll lift that up a bit closer for you. What's the resistors for the BMS? Yeah. And all the rest of it is the electronics that allows it to work and work as a BMS. So this is the connection for the temperature sensor. There's a temperature sensor in every module of these eGolf modules. Even the small double slave modules have a temperature sensor. That's all very good, and if I was able to control the eGolf BMS, I would just leave these modules where they are and hook everything all together, and that would all be good. Unfortunately I can't. I'm hoping to use the Nissan Leaf BMS, so in order to prevent this from causing any problems or any issues when I'm trying to balance the modules, I've decided to remove all of these and just set them to one side. I'll keep them, I'll not throw anything away, but for the purposes of this build, these modules will not be in the car. They'll not be in these circuit boards will not be in the modules. Now, this is where it gets awkward, because these things are an absolute pain in the neck to take out. Basically what you got to do is, there's a connector at that end, or a spring clip holding that end, so that end is easy. This is the difficult end. And what you have to do is loosen it first of all at the side, and then try and prise out that, and then loosen that side, which always catches on that, and then try and prise that out. There we go. And then just squeeze that in and pull it out. He said. It should be easy. Because I'm on camera, of course it's not easy. So there you go, that's the BMS for the eGolf. There are 8 of the larger modules that have these circuit boards in them, and they control all 96 cells. So 96 divided by 8. Each of these circuit boards controls 12 different cells in the car. And like I say, currently we have no way of using these. They can be used with Simp BMS, I believe, for monitoring, but nobody has yet figured out how to make them activate to work as a BMS. So I'm not going to throw these away, that'll be kept. I'm going to label it also. There you go. Modulating. I don't know how critical it is that this module goes back in exactly the right position, if it ever goes back into the pack, that is. But since the modules daisy chain one to the other, it might be important, I don't know. But now it'll not matter because we know exactly where it goes back. In order to connect to this, I have decided to use these connectors. And as you can see, that is a 6-way connector. And the reason I decided to go with a 6-way connector is because we have 4 modules. 1, 2, 3, 4. So that would require 4 connections to the positive end of each module. But we also have the temperature connection, the temperature sensor. Now I don't know if it's going to be important to have a connection to the temperature sensors. It might be. So my theory is, if I use the 6-way connectors, I'll have 1 for each of the positives, that's 4, plus 2 for the temperature. It's there, might as well use it. So, the thing is, I don't have that connector. I don't have any way of purchasing the male of that or female of that connector, whatever it is. So what I decided to do instead was to use this. And this is just a standard jumper for a breadboard. And what I'm going to do is to cut that in the middle. Just poke them in like that. Solder connectors to that. Put them into this. Job's good. And then I'll hold it all down using hot glue so that it doesn't wobble about and these don't fall out. So that's the plan. Now these are the connectors that I'm using that go into this. And I'll show you how to make these connections off, because for a long time I was crimping these using a pair of pliers and it really was a pain in the neck. The correct crimpers make a world of difference, so I'll show you those. And to connect to these, I've just got ordinary ring terminals, which are also crimped on. So I shall dig out the wires I need for this one, and when I've done this one, I'll then show you how to make off these ends. This is my multimeter. It's the most accurate one I have. I've actually just put up a video showing how I calibrated this. So what I'll do is let you see. That is 3.689 or 3.769 volts. 3.69. Oops, 3.69 and 3.69 volts. So that is the most negative, and you actually see it says there's a negative marking there. That's the most negative of this module, and that is the most positive of this module. No, it's not. That is. That's the most positive of this module. What I need to do is I need to put the first of my leads to this one. So this is the first positive. In fact, I'll just leave it out there. Hopefully you can see that. Yep. So that's the first positive, second positive, third and fourth. The way this BMS works is that the BMS sees the most negative side of the entire pack, and then it sees the first positive, second positive, third positive, fourth positive, all the way up to the 96th positive. So you have to have a lead from each of those positives going out to the BMS so that it can actually have a correct understanding of the voltage of each of those modules. And I guess it must measure from there to there, and then from there to there, and then from there to there, and then there to there. Basically that's kind of how it works. That being the case, this will be my first positive here. This is module number 8. This is module number 18. What I have done is I have made a little plan of each of the modules, the number of series cells that are in each of those modules, and the cell number that's going to be in each. And the reason I've done that is I want to have every module, the wires coming out, I want to have each cable with a separate label on it. And to do that, I have bought these. What I need to do is go down to module number 18, which is the one we're working at. And module number 18 has 61, 62, 63 and 64. I need to look for 61 first of all. I need to pull out number 6. There it is. Number 6, cut that off. I'm going to need 4 of those. What I need to do now, and what I should have done before I made off these ends, I should have put these on first, but I was getting ahead of myself a little bit. Now what I'm also going to do is put some heat shrink over that, clear heat shrink, and shrink it down so that it holds out nice and tight. There you go, sorted. That's the first one. And so I don't mess up and short anything out, I'll put it in now. Yep, that's in. So I should go on and do all the rest and the same throw away. I'll come back. So if you've been paying attention at this stage, you'll realise that I've just put that in to there without putting the heat shrink on it first. Oh well. We'll do this one now. Okay, so as you can see, that's now shrunk on there. It's not really tight. It can still be slid. It's still a bit hot. It can still be slid up and down the cable without any problem. It just means that now these are going to be nice and easy to read, and we'll have no issues knowing exactly what cable number that is or what module number that is. That is module number 62 out of 96. Try and get this pin out and do the same again with this. Must be some way of getting them out from the front. Yay! Wasn't so hard. It's all a bit fiddly and it's very time consuming. But that's okay. You'll just take your time and make sure it's done right. So this is 61. This is 62. I'll put it into number, these are numbered 1, 2, 3, 4, 5, 6. So I'll put that into number 2. 50-50 chance of getting it right. I always get it wrong. Just carry on like this. I need to sort out these now. Yes, what I wanted to do with this was to put the module number onto the 2 wires that we're using for the temperature sensor. Number 8 and number 1 is brown. Put these on first. So this is module number 18. What I'm going to do is to use these things. These are heat shrink with solder, low temperature solder in them. So basically all you need to do is to put these on, twist your wires together, apply heat, and they shrink and solder at the same time. Very handy. Not sure I would use them for anything that needed a lot of strength, but for something like this, it should be just fine. applied a little bit too much heat there. Oh, it'll be fine. Like I said, I don't know how great a solder joint that is. I don't believe it's as good as a proper solder joint. But for something like this, which is not critical, it's not a major issue. Now that that's done and they're nice and strong, that's alright. Now I need to put these into them. Just poke that in, poke that in. And then I'll use a bit of sticky tape just to hold them down. Hot glue gun, very, very handy. So they can't pull out now. There you go. That's all nice and secure. Okay, so now that's done. Put the last two into the connector. Doesn't matter which way around these go. It's just a resistor. It varies according to temperature. Ah, forgot to heat shrink those. Oh, you plonker. As you can see, we have modules 61, 62, 63 and 64. Cells number 61, 2, 3 and 4 on module number 18. Hopefully, with that amount of information, I won't cock it up, but I can't promise that. Right. So that one's now complete. All I need to do is put the lid on. The plan now is to go around all of the other modules and do the same.